Hello, I am Bruno Bianchi. I'm a last year PhD student at the Applied Artificial Intelligence Lab in the University of Buenos Aires in Argentina. And today I'm going to be presenting my study on understanding how our brain predicts future words during natural reading. This is our poster that you can already download from the system, and I will be touring you around in the following 6 minutes. Our motivation for this study is to understand how our brain uses different type of cues to predict the following words while we are reading. We have the hypothesis that we can use different type of cues like semantic or grammatical cues that are presented in the previous text that we already read, but there are some times, like when you find a sentence like this, what we call a memory related sentence, that can be a proverb or a song lyric or something like that, that maybe your brain changed the mechanism to predict the following words because you already know the sentence. So to address for these questions, we perform EEG studies. We already performed a previous study that is already published in Frontiers in Human Neuroscience. In this study, we perform an EEG task, a classical EEG task with the stimuli presented in the center of the screen, one word at a time. So subjects read two types of sentences, memory-related sentences and common sentences, and we found some really interesting results, like you can see here. For more details on the statistical test we use here, you can go to the original paper. This is a linear mixed model analysis using cluster-based permutation test to correct for multiple comparisons. We can see here an M400-like effect only present for common sentences and not for memory-related sentences. So this is a really interesting result that shows that maybe there are two different type of mechanisms to predict future words in these two type of sentences. In this new study, we are going to use a natural reading paradigm where the subjects read the sentence from the left to the right, moving the eyes across the sentence at their own pace. And for this, we are going to use again an EEG with 128 channel and an iLink 1000 to record the eye movements and to relate the ERPs with the onset of the fixation. We again are going to use two types of sentences, proper sentences and common sentences. If you are familiar with this core situation study, we have one main issue to solve, that are the artifacts that are generated from the eyes. These electrical artifacts can affect the frontal electrodes, but they can also affect the occipital electrodes. So you can see here that there are many drifts in the potentials of recorded from the electrodes, and we have this independent component analysis and a criteria presented by Ploch some years ago in Frontiers in Human Neuroscience to remove those artifacts, and you can see that most of the artifacts were removed after this procedure. So our analysis shows that the classical FERPs analysis, you can see here we are presenting these FERPs for low predictable words and high predictable words, both for memory related sentences and common sentences, and there are not many differences in these potentials, and this can be due to many factors coming here. For example, we are using natural stimuli, and natural stimuli has too many variables that we cannot control at the same time. So maybe this type of analysis is too limited to achieve for these results. So we again run a linear mixed model analysis. In this analysis, we can test for all the variables at the same time. So you can see here that we address for the position of the word in the sentence, for the predictability of the word, and not only if it's high or low predictability, just the predictability as a number, and the first fixation duration of the fixation in the fixated word. And all of these variables are tested both for memory related sentences and common sentences. This is again the same procedure that I presented before that you can see in my previous paper. Our results in this data suggest that there are some differences in the processing of memory-related sentences and common sentences. There are many differences in the potentials that you can see for all the three variables, and these are preliminary results. So I would like to have some feedback from you to understand better these results. So in conclusion, we have no differences in the classical FERP analysis. We have some interesting results that you can see in the paper, in the poster for the time frequency analysis, and we have these interesting results for the linear mixed model analysis.